So we are doing question 41 on 4.9, and it's a four-part question, and it starts, a stone is dropped from the upper observation deck of the CN Tower, 450 meters above the ground. So the information we know just from there is that velocity at time 0 equals 0, and the position at time 0 equals 450. And, okay, so A asks, find the distance of the stone above ground level at time t, so it's asking for the position function. And so what we know from the beginning is that the acceleration equals negative 9.8. Because you're dropping it, so the only force acting on it is gravity, and gravity is negative 9.8. And it's moving down, so it's negative. And so you take the antiderivative of that, velocity of t equals negative 9.8 t n plus c. And then we can stop there and find c because we know that velocity of 0 equals 0. So we just plug in 0 for t, and you get, so 0 equals c, so c equals 0. And so you just cancel out the c, so velocity of t equals negative 9.8 t. Then from there you take the antiderivative of velocity to get the position function, so it's negative 9.8 divided by 2t squared plus d, and from there we can find what d equals. So you just plug in our information that we started with, so 450 equals negative 9.8 divided by 2, 0, so d equals 450, SOT equals negative, 4.9 plus 450. And we are going to erase this for part B because my handwriting is ginormo.
So now in part B, it says how long does it take the stone to reach the ground? So we're looking to find S of t equals 0. So we're going to write out 0 equals, and then the S of t function, which is negative 4.9 t squared plus 450, and so we can factor, but that's kind of ugly. So what we're going to do is we're going to subtract the 450 from each side, and then we're going to divide Okay, so now we are going to see that 91.837 is approximately t squared, and so then we're going to square root that. We're going to come up with 9.583 is approximately t. Alright, so now part C. C says, with what velocity does it strike the ground? So we figured out the velocity, or we figured out how much time it takes for the object to hit the ground. So now we can use that and plug it into the velocity equation that we have. to solve for the speed it hits the ground. So we're going to do v of 9.583 equals negative 9.8, and then in parentheses 9.58, that's not happening, 9.83, or 9.583, sorry. And so all we have to do is find that velocity. We're going to just multiply that other side. Is approximately negative 93.915 meters per second. So remember all this information, but we're going to erase for part D because we need a little more space. Okay. Hey, Jake. Alright, D, I screwed up a little bit. Oh, that's good.
Okay, so for D, the question is, if the stone is thrown downward with the speed of 5 meters per second, how long does it take to reach the ground? So here, what's changed is before the velocity at 0 was 0, but now the velocity at 0 is now 5. So the change is v of 0 equals negative 5, because you throw it downward. So the acceleration is the same, but the acceleration of t is still negative 9.8 because not t is negative 9.8 because gravity is still the only force acting on it when it's falling down. So you take the antiderivative of that, negative 9.8 t plus c, but instead of c equaling just 0, now c equals 5 because you plug in 0 for t, so you get 5 equals c. Negative 5, sorry for forgetting that. Velocity of t now equals negative 9.8 t minus 5. And then so then what you do is, I don't know. The video won't pause. Okay, from there you take the antiderivative to find the position function. Plus d, and then you plug in 0 for your t's, and so you get, and t, and then you plug in 0 for your t's and 450 for your position function.
Did you do it? You haven't done it yet.
And so 450 equals d, so your position function is now
In most cases, fine. Okay, so this is problem 25 from the book, section 4.1. And
I don't know.
this is the left.